You're gonna learn today. You're gonna learn today.
Yeah, what'd you get on the last test? Really? Oh, wow. I got like 3. Gotta remember what we're learning today. Write everything down. Alright, so it looks like we're going over Newton's method today. Have any of you heard that before? Who are you, little guy?
Oh my God, who the hell cares?
Here, take a Xanax. The method is very important. In fact, it's used every day in life, many times by many people. Are you writing this down? Yeah, that's what I thought. Does anybody know exactly what I'm talking about? No one knows. Okay. Just gonna write this on the board. Sorry about that. Yeah. All right, so yeah, that says Newton's method, aka Newton-Raphson method. Yeah, that's used successfully for finding better approximations to the roots, zeros of a real value function. Do any of you have any idea what I'm talking about yet? Do you know anything? All right, well, Piechnik. Alright, so now we're going to look at this example from the book. It states, I wanted to go hang gliding. That doesn't sound safe for someone who's mackie. But here's my big fear. Other than heights, I'm hang gliding and, say there's some place I don't want to land. But it looks like I'm going to land like a pig pen. Like in a pig pen? Now as I'm hang gliding, I'm trying to land and I'm trying to determine whether or not I'm going to land smack dab in the pig pen. So let's plot my height as a function of a distance along the earth. I'm just going to read for now and then draw you an example on the board after I'm done. I'm traveling along this line here. When I get, let's say 100 yards up, I look down and I say, oh no, on my current trajectory, I'm going to land in the pig pen. How did I determine that? You know? Okay. I looked at how fast my height was changing as I was moving forward. When I say this, I mean that I really looked at the slope of my height as a function of distance line. Unfortunately, now it looks like I'm going to land in the pig pen, so I closed my eyes for a few minutes. When I open them, I'm actually a lot farther away than I thought I would be, and I haven't hit the ground yet. I thought I would hit right here in the middle of the pig pen, but now I'm that far over it. And you'll know what that means when I draw on the board. I'm right above the spot that I thought I'd land in, and still a good 100 feet up. So now I want to estimate where I'm going to land. I feel like we keep talking about this, and we're not going anywhere. I'm beyond the pig pen, but maybe I can figure out exactly how far over in this field I'm going to land. The field that will be on the board when I write it on the board. Landing point, we could use Newton's method, that thing that you have no idea about, and we're going to figure that out. We can use this information about derivatives that we've been going over the past semester, and do not look at him, talk to him while we're in class. Yeah, well thought. That is my current trajectory to find roots where things can go to zero. Isn't that cool? Isn't that cool? I'm cool. You're cool. Let's be cool up here on the board with an example drawing. Oh yeah, I threw it over here. So basically, this is what this looks like. Got a graph of the height. There's a girl out in the hallway. Yep, and this is me. Smiling. This is distance. This is a pig pen. In reality, this is just a 0 point on the x-axis. This x-axis represents the distance, so if I start falling, kind of looks like a parabola. Ain't that fancy? Alright, since we've used an everyday example, I think maybe we can step it up a notch, actually make it a little bit mathematical in a sense. And we're going to do this. I'm going to show you the equation behind Newton's method. And it looks something like this. And if you want to reference this and look at this and find in your book, you can see this as well as work on problems involving this equation on page 315, and this is example number 5. Okay. Piechnik. Alright, so before I pick someone to come up on the board, I'm not going to have you guys do this question. You're not smart enough for that yet. And also up here, when I did this, made a mistake. This is not the derivative of x. That is just f of x. And all right, so can we get a volunteer to come up and do number 5 on the board? All right, so since no one's going to say anything, we'll have you. Yeah, I'm just chilling in your seat. Standing up too long. Oh, this little cross is going to be sore. 13 miles of running yesterday.
Four decimal places would be 1.1797, Professor.
Yeah. Right. Okay. Alright, so that kid didn't really explain it very well today. Now, so we're going to have you. I'm going to have you go explain to the class. Yeah, right.
So basically what you do is they give you x sub 1, which equals 1, so you plug it in here on this equation for x. And then you plug it in for the f of x and the f prime of x. And you find the new value of x2, I guess. And then you plug that in for the next one, and you just repeat it until you get to x sub 3, or whatever the problem is asking for you.
That's good, but I don't want the class to forget that, oh man, you have to take the derivative of this, because even though I wrote up here originally that this is the derivative of x to the n, this is actually just f of x to the n, and this is the derivative of f of x to the n. So that's the first thing you do if you give in f of x, as long as it's set to 0. And other than that, I'm pretty sure you explained it correctly. Now, you and your fellow classmates got an in-class assignment. I'm not going to call it a quiz because I don't do things normally. I gotta go run 14 miles, go to Walmart, buy some ginger ale. The SI will take care of you. See y'all next week.